Welcome to IoT Builders, a live stream where we discuss a range of topics. Sorry, there is an echo. Okay, so sorry about that. There was an echo on my side. As I mentioned, welcome to the IoT Builders, a live stream where we discuss a range of topics on the Internet of Things, from embedded devices to cloud services, all from an IoT Builder perspective. It is a March 29th, and this is the episode 22 of our weekly live stream. My name is Nenad Ilic. I'm a senior developer advocate for AWS IoT. And today I'm joined with my colleague and co-host, Alina. So, hey, Alina.
Hi, Nanad. Hi, everyone, and welcome to our IoT Builders episode. My name is Alina Dima. I'm a senior developer advocate also for AWS IoT ecosystem services, and I work more on the consumer and connectivity services like core and device management.
Excellent. And today we have a special guest, Olivier Bloch, who is a longtime expert in the field of IoT as well as developer advocacy. So, hi.
Hey, Alina. Hey, Nina. Thanks for having me today. How are you guys?
Yeah, all good. What about you?
I'm good. Yeah. So as you were saying, because you guys made a short introduction about yourselves, my wife wants me to call myself an IoT whisperer. She says it's cool. I've been in the IoT space forever. You might know me for the IoT show. I've been a developer advocate for Microsoft embedded and IoT technologies for a long time. I'm open for work these days. But prior to that, I was an embedded and real-time developer in the industry, building some cool stuff, some that I don't have the authority or authorization to talk about, some that are, I've been embedded into cars and other things like that. And then moved on to evangelist, which was to me a cool job that allowed me to express, my my passion for these technologies and try and convert the world. I did that by staying as close as possible to technology and product groups. So that's me in a nutshell.
That is excellent. Thanks for joining us here and sharing all of your expertise and what you have been doing so far. Coming back to this, I know that we talked about this term IoT developers. Maybe we can start with that question. So, like, what is an IoT developer from your perspective?
From my perspective, the best answer is it depends. It depends who you talk to. It depends what kind of IoT application and what areas in an IoT application you're talking about. IoT is about connecting devices, sensors, and extracting insights from the data they can produce, as well as controlling them, and then make sense of that data in a context to then implement some workloads or intelligence into business apps, into other things, as well as provide to operators of systems and machines with the right tools for them to operate efficiently and safely, in their day-to-day. So IoT developers, for some, are the ones building the devices and connecting them, the ones creating software that goes onto these devices, and very specialized type of software very often. For others, IoT developer is the one who is integrating these devices into broader applications, connecting them, managing them, eventually leveraging some platform in the cloud to have that connectivity being safe and authenticated, and then having applications that will feed from the data from these devices. And so it's a wide range of individuals that go all the way from hardware slash BSPs and OS engineers all the way up to cloud developers, and it spans across different types of technologies, different types of knowledge and skills, languages, and whatnot. And so when we talk to IoT or about IoT developers, once again, it depends who you're talking to, what kind of conference, what kind of media, what kind of asset, and so on. And so yeah, that's my eternal response for that. And that's super hard for us as advocates, because we always have to explain who we're talking to, and we need to bring the technologies to different types of audiences in a way that they understand it, even though it might not be their field of expertise.
Yeah, no, this is exactly what we've seen happening so far. But I think maybe, sorry, the things might have been changing. So I don't know for the future landscape. Do you see that kind of like there is a certain person who can say, I am the IT developer because I can actually write, some code for microcontrollers. I can write some things that can go in the cloud and all that kind of stuff. Maybe you can share what you see as a future landscape for kind of that IoT developer, and how is this going to change in the next 5 to 10 years, if it's going to change at all. Which I
Oh yeah, well, it's ever changing, right? It's and I would dare to say it's even changing faster these days, right? With all the hype around dev tools that are powered or will be powered by AI in many ways. But I I think there is something to say about the fact that in general, developers they have to be more open to go beyond their favorite developer language. They have to understand what their app and software will be running on and in which context, right? If you're a hardware guy and you're developing OS code and drivers and things like that, now that your embedded device will be connected and be part of a broader application, we'll have to communicate with others, we'll have to authenticate it, we'll have to, and so at the end of the day, you need to understand the broader context. So even if you're an embedded developer, you need to understand what a cloud application is about, what it's made of, and eventually how to play around with it, because you need to test your devices and how they connect and so on. And then on the other side of the spectrum, the people who are building these applications that will integrate an OT environment with IoT devices, sensors, and so on, or a smart building environment and so on. They need to know what a device is about, because like typically they need to understand that the device, if it says it's disconnected, might not be because the device has a problem. Might be because it's a battery powered device that had to shut down and will come back to life tomorrow, to just send a little ping saying, I'm alive, I'm good. And you need to take all of that into account, understanding what these technologies are about. You don't need to be an expert of how the device goes to sleep and then recovers from sleep and sends the ping and whatnot, but you need to understand that it will do that. And so that means that you need, as a developer, to be more and more aware of the context of where your app will be running and where your software will be running, and how it will be used by other parts of the broader application. The other thing is the focus, I think, of the technology. IoT is becoming, in my sense, mainstream, and we're seeing that in all the big tech companies these days. Some signals might make people think that, hey, IoT is dead. Well, actually, the term IoT might, as in, do we need to have a buzzword to describe something that is as fundamental as your plumbing or electricity in your house? Maybe not. And so the term IoT might disappear in product names and so on, but the technology is the foundation of what I truly believe is the future, at least in that realm, which is that industrial metaverse, that metaverse story, which is about connecting or representing a physical environment and all the people in there in the digital world to be able to interact with the physical world in a safe way, as well as provide an interface for operators, for consumers, into the data, into the sensors and devices and the environment that is practical, intuitive, safe, and productive. And so at the end of the day, the way things are changing is that you will be more and more, as an IoT developer, part of a broader story that includes things that are way higher level, more business impactful, I would say, and unfortunately, sometimes you will be forgotten as an IoT developer, because the technology has to work. It has to be there. It is pervasive. It is key to all these scenarios and foundational. Developers in that realm need to understand that. And that's one of the ways I think it's going to evolve.
No, this is exactly what we've seen as well. It's like the IoT as a whole is technically just a infrastructure that allows for those developers to kind of develop those applications throughout that stack. And nowadays it's like, okay, this is expected to work. We need that infrastructure. but again, those people who are developing on different parts of the stack, they need to understand, as you said, the other parts. So like, how do I communicate with the cloud? How do I communicate with the edge devices if like I'm running on a constrained device, all that kind of stuff. I know Alina has been talking about a lot of observability and around the whole stack. I don't know. Do you have any questions in regards to this, or?
Well, I mean, I just want to say that I completely agree with what Olivier was just talking about, because it is, I mean, I think with IoT, it becomes more and more obvious that it is an ecosystem. I mean, when you're dealing, for example, with distributed systems or web applications with backends, you do have full stack developers, but then the difference in technologies is not that big as it is in IoT, which is, you know, an ecosystem. So you've got network protocols, you've got connectivity protocols, you've got hardware, you've got software, you've got multiple types of software. So it's just obvious that that developers need to understand on a high level what's happening at every, you know, point. And another thing that I find interesting is the part about embedded engineers, right? Because I think they need to worry a bit more about what happens outside of what they produce to run on one instance, right? So, I mean, you create a little app, it runs on your hardware, you're super happy about it, it connects to IoT, to AWS IoT or some other IoT system, you know, some other broker, and then the cloud engineers come to you and they're like, what are you doing? You haven't implemented any backoff. And then you suddenly have 1 million devices all connecting at the same time. And, you know, you're destroying my cloud application, you know, this kind of thing, if there is no communication and understanding.
Yes.
Yeah. Agreed. And I think, Alina, to complement what you're saying, which is spot on, I do believe, and you just hinted to that, there will still be specialties and there will still be silos or niches where we need to have like deep dive experts, like an embedded developer will still be needed. I do believe that at some point we're going to have a way to develop for embedded devices in a way that is like codeless, and you just like bring, drag and drop. I've demoed that myself, and M5 Stack has some interesting technologies there. And then on bigger devices, you have Node-RED and other technologies that makes it super easy to build an application that runs on a device. But you still need experts that will be able to run in an optimized way this kind of software, the underlying layers, right? So if you think about big operating systems, you know, Linux, Windows, Mac OS, all the lower layer stacks are developed with languages that are as close as possible to the hardware and optimized. And you need to have experts. Not everyone knows how to develop and write a driver for Mac OS or Windows or Linux, right? And that's fine. And we still need experts in that domain. But we also need to have more and more of these developers who are more pluridisciplinary. And the other aspect, I think, of the evolution of these technologies is the fact that because IoT is becoming mainstream, and I don't know which one is the, you know, the chicken and the egg, but IT technologies that have been, you know, developed and used and improved over the last decades for security, for monitoring, you know, as you were mentioning, Alina, for management of devices or assets, for distributing intelligence, and then we'll talk a little bit about Kubernetes and this kind of things, for communication protocols like MQTT becoming some sort of an industry standard for IoT technologies. The fact that these technologies are becoming more, you know, pervasive and you know, integrate IoT developers need to understand them and use them. And now we are at a point where you can start thinking about hybrid, cross-platform, cross-cloud, and for your applications that include IoT technologies. And your devices will be connected not to a cloud or one cloud platform, but will participate in an infrastructure that might be hybrid with things at the edge, things in the cloud, maybe different clouds, because your customers might be using different clouds and you need to route the data to different places. And so developers need to be conscious of that kind of evolution, but they have the chance of being able to benefit from industry standards that are deploying towards the edge. They're getting closer to the IoT infrastructure, or vice versa. IoT is being more and more integrated into this kind of distributed architectures. And that's something that you need to build new muscles, learn new technologies to understand better, you know, what your device will be integrated into, or what kind of devices will be integrated into your application if you're on the other side of the spectrum, and so on. So that's, to me, the standards and the way we can move them forward by adoption, also by community work, like you guys are doing, you know, engaging with a community without a bias, but with a strong, a strong will to make things work and to find the best technologies for addressing specific problems. And so that's to me key. And the work we are doing like together, emulating these communities of developers around these technologies to explain them to them, to develop their understanding of how their work will have an impact on a broader solution and application, and how they can leverage these, long developed technologies from the industry, and learn new things. I think all of that activity is key to make all of that work together.
Yeah, no, definitely. This is like a interdisciplinary thing. I mean, I think you mentioned this as well. Is like, you have to have those expertise. Somebody needs to build an operating system that is fitted for that specific device. Somebody needs to make a mechanical enclosure if we're talking about like consumer devices or whatever. Somebody needs to do kind of a DevOps infrastructure build up that's in the cloud. So all of that is important in order to allow like people just writing this small business logic and this differentiating things on top of that. So yeah, that's definitely an interdisciplinary play. And we did talk about this kind of like partners and being engaged and kind of building out that kind of use case.
And then I think you're right to mention the fact it's not just about developers or electronics engineers or hardware engineers. It's also about other types of engineers who are now getting involved. And I want to bring that buzzword back, which is industrial metaverse. Yes, it's a fancy buzzword, but that word allows to rally and to bring together different disciplines, different types of engineers. And typically when you create an IoT application that will, for example, be about monitoring your high temperature furnaces for melting glass, well, the ones who know how these furnaces work and how the sensors need to be calibrated, what kind of information is interesting from them, what kind of sensors, the ones who know about that have never written a single line of code in their life, sometimes or very often. Or you need to have mechanical engineers who are coming and explaining the physics and the mechanics of things for your application and the positioning of the sensors and the meaning of the data that these sensors will produce. And so now you need to have many different types of engineers understand the technologies, work together. And that's bringing me back to the notion of we need to democratize, the technologies, the way we talk about them, so that all of these different types of actors can understand each other and can work together around what's key here, which is the data that is making the money to the businesses, right? And we are all about that these days. We can lie to ourselves, but that's what we're looking for. And so having everyone working together by understanding what they're working on, I think is key, is fundamental.
No, I really like this concept. I remember, in school, like we always were doing this. You have a, you derive a mathematical model out of like physical things, and then you solve some equations. You come to some results, and then you test it against the physical model. So if we can do the same thing, what you just described, and have those models in this kind of industrial metaverse, what you're calling it. And I'll come back to this to explain even further, like what that actually means nowadays. But, if you can have that, that will simplify things for you to do more simulations and then solve equations or get that data to get some insights. But coming back to this, so can you briefly explain this concept of the industrial metaverse and like, what are the myths and the realities associated with it? I'm really interested in this.
Yeah. So the first one I wanted to debunk, when we hear metaverse, we think about Spider-Man, or we think about this virtual reality or augmented reality environment where we are meeting people who are not here, or we have avatars and so on. And so I wanna bring up the fact that metaverse, as explained or known by the social media, or as demonstrated very often, Metaverse is not just and only about the virtual environment you're evolving in. Metaverse is actually mostly about putting that physical environment in a digital format so that we can interact with it, with the physical environment remotely, safely, or that we can augment the physical environment with information coming from the digital world. And so the visible part of the iceberg is the augmented reality and virtual reality. And they're cool technology. You put your glasses or your whatever on, and now you're seeing things, and it's fantastic, and it's real-time data. Like the new blinky LED for IoT now is showing temperature data overlaid onto an actual device, right? But that's the new type of fancy blinky hello world that we're building. But that's the tip of the iceberg. All the underlying technology that are about connecting these sensors, gathering the data, putting it into some storage that allows you to organize the data in models, putting these models and this what we call twins or whatever in relations between each other, creating bigger models and bigger twins. And then having graph that allows you with simple queries to access all of that data coming from different places and sources in a very simple and intuitive way. That's what the metaverse is about. That's what the industrial metaverse is even more so about. The industrial metaverse being the application of these technology to industrial domain, not just industry, like Industry 4.0 and manufacturing, but also smart building and health and all of these industries that will require that digital version or replica of a physical environment and physical things and physical people to be able to more rapidly, more efficiently, more productively interact with that environment and extract the insights, as we're saying, and take action based on these insights. And we're still like, by the way, we're still saying the same things. Like 15 years ago, we're talking about smart devices, and suddenly we talked about connected devices. And after we started talking about to describe cloud services, we started talking about things, data, and extract the insights and take action. And this is still exactly the same thing, just like way more cooler technologies to do all of that.
Yeah, I remember I was doing like this SCADA systems back in the days, right? It's it was popular back then, like 15 years ago, but it seems we are going full circle now. So
yeah, exactly. And by the way, it's funny you're bringing SCADA and the especially the manufacturing industry is an area where you had to do a lot of things around security and so on. You still have today, because the manufacturing world is made of devices and solutions that are lasting forever, right? Like 10, 20, 30 years. And so we need to integrate them into modern applications today. And I want to bring back the importance of edge compute and IoT in general, that are in part about integrating these brownfield scenarios and infrastructure into the modern world of the industrial metaverse. And this is even more so, great, because we need to educate like old timers who have the tribal knowledge about ancient technologies, I would say, into modern applications, modern distributed applications. And that's, to me, that's fascinating. That's really cool.
But it's also interesting because now you have, again, coming back to the collaboration part, because now you have additional people who are like doing those 3D models, doing the VR application, doing the, other things as well. So I'm wondering like how then the collaboration between this IoT developers and other industry professionals, like how does that help drive innovation in this industrial metaverse?
I think what they all need, and that's back to the previous conversation, they all need to have technologies that allows them to work together. We need to be able to simulate the devices so that the one building the VR, AR environment has actual data that looks as close as possible to what the real device will send, right? You need to be able to simulate an environment, hence digital twins. Digital twins allowing to recreate or to pre-create, I would say, a model of an environment before it even exists. You don't need to have the actual environment to start working on it, with it, simulating the data in a way that is as close as possible to reality, simulating things and extreme conditions is something that is also doable thanks to digital twins and this kind of technologies now. And so these technologies are the ones that will and tools are the ones that will enable these different kinds of developers to work together. Or I like your term builder. It's no longer about developer, which now is a term that is more associated with writing code. Builders, at the end of the day, might be a better term to describe these people. And I'm now just realizing now, how smart the title of this podcast is, because it's not just about developing code. It's about building, distributed, intelligent, modern applications that span across hardware, software, cloud, edge, whatever. It's and real life at the end of the day. And with AI coming super strong as well. And we've not even started touching about it, but it's that's the technology. And we are technologists, right? We're passionate about that, and for good reasons, because with them there's no limit, right? It's infinite possibilities here.
Yes. And I also like this builders term, is because if you think about, we have taken a lot of this kind of naming from the people who are actually building buildings or infrastructure. So it's like, we are IoT architects now, we are IoT builders and all that stuff. But it makes this kind of analogy of what we've seen in the past as well. So that's kind of where this is coming from. But that being said, now, like what you mentioned, generative AI and things are coming. So how those IoT builders or developers can adapt their skills, to better align with the emerging trends of the industrial metaverse.
I might sound like the old timer here, Gen X guy with seen it all, but so this is not new. The things have been evolving more or less fast, these times faster than previously. But at the end of the day, this has always been coming. The fact that compute augmented by the infinite resources that cloud allows and permits, and the acceleration as well as of the hardware, in form of GPUs and microcontrollers that can do more and more. The notion of distributing your intelligence is something that is coming back really hard with the upcoming of AI, because a good AI is an AI, unfortunately, like we're seeing in all these doom movies, is about being everywhere, right? So you need to bring that intelligence, distribute that intelligence, and bring it as close as possible to the sensors, the data, because we have so much bandwidth, and the data is so precious in terms of privacy, in terms of security, in terms of safety, that we need to be able to leverage technologies that will help distribute your intelligence. And when I was saying, like, I will sound like the old timer that has seen it all, robotics has been forever trying to address this notion of distributing workloads to have nodes. The notion of node is, to me, is something that we'll hear more and more about again, and distribute your intelligence across nodes that can communicate with each other, that can collaborate in order to implement a bigger system, right? And very often in an autonomous way. So you need to have a level of intelligence that allows to adapt to an environment that is ever changing in order to implement smart applications. And I think the AI is accelerating, and its use in industrial environment will accelerate thanks to technologies like Kubernetes, also the enhancements of TinyML and this kind of hardware plus software, optimization of AI engine and models for tinier devices. These will accelerate the use of AI in a distributed way that will allow to have some level of intelligence running down there at the edge. And when I say that, that's not something new. We've been talking, as I was saying, about intelligent device forever. Robotics has been there forever, trying to solve that notion of distribution and orchestration of workloads. And now we're seeing more mature technology that have been developed for the cloud,
Yes.
where resources were infinite, being shrunk down and now optimized for smaller, tinier hardware at the edge. And I think this is something that IoT builders need to ingest, need to really integrate,
Yes.
if they want to survive that AI wave. Not that they're going to be replaced by AI, not that AI will do it all. On the contrary, I think IoT builders will be more and more necessary to have systems that work at the edge, because the edge is the mechanic part, is the sensor part, is the chemistry part, is the physical
Yes.
part. These are all the physical environment, real life environment parts that are key for AI, because AI doesn't have any use if it's only virtual. It
Exactly.
has to be interacting with the physical environment and world, and this is where IoT builders are key and important. But they
Yeah.
need to be able to adapt to that and understand how AI can be used in a responsible way, as in their realm, in their domain.
No, I really like this from like two perspectives. So number one is, what you said is like things are repeating. Is like I was fortunate enough to work on like Linux kernel, and I remember there was like two things that on top of all of this is like the IO, the input output, and then the scheduler. So those were the two components that always were like debating in Linux kernel, and they were trying to make it as fast as and efficient as possible. Is like, okay, how do you access the peripherals, and then how do you make sure that the applications you are scheduling are done correctly, and then you have the real time and whatever. And then what you said is exactly true. Like what we see now with like this high level applications, now we have like something like Kubernetes or other orchestrators that are basically doing the same things. Is like they're orchestrating those applications, but not only now on like one device that has a certain IO and sensors and actuators, what you said, but to have them like spread across, and then making sure that the right application is scheduled on the right machine node, whatever you want to call it, that has those sensors and actuators that are needed for it to be operating. And the second thing I really like about this, what you mentioned, is that from the user experience, and we touched base on this briefly before, from the user experience perspective, if you want to reduce the latency, you always need to have the application running as close as possible to the end user, to the end use case. If you have it running in the cloud, and then like we talked about, like you have a sensor, and then the data needs to go to the cloud, and the cloud application needs to determine what to do with the actuator, you cannot afford that latency. And then not only from the perspective of time, but also like from the amount of bandwidth you will be consuming, also the law, like from the security perspective, from the restrictions perspective as well. So yeah, I really like how you laid it out. And then coming back to the IoT builders and the developers, they need to also have that level understanding and kind of go and dissect all of these points, which is difficult. But again, now we have a tool that can help us out, a partner tool that can help us out with this.
Yeah, great. And I think there's another aspect of IoT development or building that is evolving really fast, and it has been evolving for some time. But I think the era of edge compute that is coming super fast will accelerate that, is DevOps. The developers in the realm of IoT building, especially on the hardware side of things, on the OS, BSP, real-time application side of things were very much like handmade in terms of, or custom made in terms of DevOps, right? Your development cycles required specific hardware to deploy, debug, test, and you were not able to really test an application until you had the final hardware, and then you were debugging the hardware with the software, and software is debugged using the hardware, and so on. And you just like, development cycles were like super long. Now we're starting to see that, because more of the intelligence of these intelligent devices will be distributed, right, and happening on bigger, beefier edge devices like gateways and server on racks in the factory floor and things like that, you'll be able to leverage more and more of these DevOps technologies, where you'll be, in your GitHub environment, and you will just like check in your code and then commit, and then suddenly, you will have a deployment of your new version of the app onto simulated apps or simulated devices, and then to real devices to test, and And Lena was talking about monitoring and surveilling, I would say, this kind of processes. Well, DevOps and all that comes with it are things that we IoT builders need to be more acquainted with or more familiar with, because that's becoming part, if not already part of the day-to-day tasks and jobs for IoT builders. You need to integrate into an infrastructure that is initially has been developed and optimized by IT for different types of applications, and now they are usable and they are actually efficiently usable for building IoT apps as well. And so that's something which is also important, following the trends of AI and how the apps are evolving, as well as following the trend of toolings. I've not played yet with Copilot tools into GitHub and into code and other tools like that for IoT specifically. But I've seen some Chat GPT prompt creating Arduino code for doing this and that was pretty good. Now I'm curious to see if we can create C++ code that is hard real time, using this kind of engine. I'm curious to see that. Actually, I'm fairly sure it's possible and it will look good. But for having been myself debugging at the assembly level real-time systems and applications, I'm curious to see how ChatGPT and other bots will do there.
Yeah, me too. I'm curious to see that kind of that thing as well. But I really like what you mentioned there is in terms of like this industrial metaverse. I'm coming back to this because it's kind of like mind blowing, and then at the same time we see different technologies popping up. Alina also, I think she was talking about this in the past. There's this kind of like a virtual hardware nowadays as well. So coming back to the industrial metaverse is like not only that you can now simulate your temperature readings and whatever not, but you can actually simulate the devices, that constrained devices themselves. I know ARM have their own like virtual hardware for Raspberry Pi and so forth. So technically speaking, and coming back to what you said, is you can now start developing things, go through iterations in a completely simulated environment. So maybe one day the developer will be simulated as well. I don't know. That might happen as well. But and go through that fast iterations.
Yeah, and that's interesting what you're saying. The developer might disappear, and maybe at the end of the day, developers will become these guru experts with the tribal knowledge, will know how things work underneath, right? And can decrypt and debunk what an AI is doing wrong. And there will be very few of them, and there will be the last Jedi's. And so, and I'm sure they love that we describe them like that. But there's also, and you were talking about the simulating of hardware, things like Wokwi or Renode are very interesting technologies that indeed allow to no longer just simulate, but really emulate the hardware by delivering a behavior that is exactly the same as the ones in the real environments. The only thing that is different is the actual source of the data, the temperature itself, where it's hard to simulate nature. And we now have models that are very advanced that can do a lot of that can be applied to inject a simulated scenario of a temperature change, so that your application that is running on an emulated version or simulated version of your hardware can be tested for these extreme situations. And you need an integration testings for IoT apps, whether they are hardware on the device or when it comes to integration, once again, all the way up the stack to the freaking dashboard for the operator. All of that can be simulated at scale. And that's a new way of doing things. And you can deploy a full environment in a matter of minutes, if not hours. That is fully functional. That would have taken a couple of years to develop just a few years ago. And so this is something that you can become one of these Jedi's, and being one of the left expert in a specific silo and domain, which is great. We need them, but you also need to become more of a builder than a developer when it comes to IoT.
No, this is exactly. It's a pretty interesting future, I would say. But yeah, so what you're also mentioning, I mean, having that kind of a DevOps point of view as well, and having that infrastructure that from the user perspective, who is developer those application, is kind of having that kind of GitOps, let's say, user experience, which at the end of the day, the output of a developer is that source code that needs to be checked in and version and whatever not, and coming that to kind of like have it in a way that stretches out of the data center and goes to the devices is really hard. But again, it's something that is kind of interesting to work on. So maybe you can share some light on that, orchestrating workloads and what you've seen in the industry so far, setting the standard. I know you mentioned Kubernetes.
Yes.
But yeah.
Well, I think we've seen an evolution of the way apps are containerized, based on the development of microservices in the cloud. This been in the last, I would say, 10 years, 5 to 10 years, there's been a trend towards, well, first, development of cloud applications was infrastructure as a service, where you could benefit from the networking, the storage, the compute, and build your applications in the form of VMs that were running on someone else's computer somewhere, right? And then it evolves towards platform as a service, where services were managed for you and are managed for you, where you have a set of parameters and a functionality set of APIs, and you just leverage that functionality. You don't have to care where it's deployed and so on. You just have to configure it. There's been, I wouldn't say an attempt, but there are some areas where it works pretty well. There's this notion of SaaS, where software as a service goes beyond just the configuration of workloads that are managed for you. It goes all the way down to having a turnkey solution for a specific vertical or type of application that you can just leverage. And I think these days there's kind of a return towards more of the elemental bricks, the PaaS services that bring functionality that are unique to them for security, for authentication, or monitoring. And we're seeing that we can containerize these functionality, and we start seeing that we can deploy them. Sometimes you need to have part of your authentication and data analytics that happens, in different places in your application because of latencies issues, because of privacy issues. Once again, the core of all of that is the data, that goes from one place to another one. So you need to optimize, you need to secure, and the ability to deploy and distribute workloads in the form of containers is something that has been key to accelerate smart application and distributed application development. The technology is getting better and better, and the technology is now being approached from the perspective of how can we make it smaller to fit smaller devices, because not everything is a server or a cluster of servers. As a matter of fact, it would be great if we're able to have a container-like technology for microcontrollers that participate in a scenario where you have one pane of glass for distributing, deploying, monitoring, managing your application end to end. And when I say your application, I'm saying all the bricks that compose your application. And we're getting there. I'm fairly sure that we're getting there. The limit of the containerization, we're going to hit a wall at some point, but then the last mile, the last meters, I would say, are things that will still be specialized, but that's fine, because now we're going to have interaction between that edge container technology and the physical world that would be as small as possible, and a one way to manage these applications end to end. And I think this is what the containers technology have brought. And now with Kubernetes, the orchestration of these containers are changing the way we're doing IoT applications and services. And as a matter of fact, I think this trend of the industry, which is just arriving. I mean, like for us, we've been in the IoT space forever. We know that things evolve slower in that domain, especially when it comes to industry or medical devices, where there's a notion of safety that implies being super careful and slow in the way you're evolving technologies, because testing is really important. That's going to accelerate with digital twins, I'm sure of that. But we know that this is coming, and this is making things change. And we know when we hear about big tech companies that are killing their IoT business units, they're not really doing that. Whether it's like IBM, Google, Microsoft, it's not a matter of like killing IoT. It's a matter of visualizing where it's going in the next 5 to 10 years, where these technologies that are IT technologies, cloud technologies, are coming to the edge and are removing the need for specialized services for IoT. These like more mainstream type of solutions will IoTify themselves,
Yes.
if you will.
Yeah.
And that means that, and that's, to me, that's the right bet. I'm not saying that IoT developers or builders that we know them today will disappear. On the contrary, because they will adapt, they will learn, they will enjoy new ways of building applications end to end. They will still be able to tinker with their soldering iron and playing with LEDs and so on, because that is essential, as I was saying, to all these scenarios. But they will also be able to benefit from these container distribution and orchestration technologies that are coming really hard towards the edge. And I do look at all these big players in that realm. They're all playing that card of, and they they're looking at the trends, they're looking at their customers' needs and asks, and that's, some of them are reacting faster than others, and they're once again leveraging industry standards, Kubernetes being one of them. It's something that the industry is agreeing on as being the way to do it. And well, there's not many options, I would say, but because this one is a good one. But at the end of the day, we might see another one emerge that is very similar and does similar things. And that's good. That's great. We need this kind of competition. And I hope that we'll see one that comes with a container-like technology for real-time systems that will allow you to do the same thing there, in at least in concept. And so, I think this is something that is super important for IoT builders who are listening to pay attention to, because this is the platform that's going to also allow distributing AI. And this is the trend these days. So don't miss that wave.
Yeah, something that I've observed, and actually I did a bit of prototyping as well, and I have started this blog series. Is for what you exactly said, it's like what we've seen is things being containerized, and one of the reasons why let's say the Docker file as it is kind of made progress is because the user interface was kind of easy. Like, you have a Docker file, you just say, okay, I need this, I need that, get from here, copy this here, and then run, right? Even though like the C groups and that thing existed beforehand. But what I'm seeing right now is like big trend going into this kind of like WASM, where this might be, again, this is just speculation at this point in time, but there is a certain signal from the community. Is like, since you can write, in any type of language that is able to compile to this WASM, so that could be Rust or even Python and so forth. You might not need that full-blown containerization as you would with like using the Docker and Containerd and that kind of stuff. And then you can also have basically the WebAssembly interpair on even smaller microcontrollers that does not have the memory management unit. So coming back to what you said, that might be, as of now, what we see as the best technology emerging that can have this similar user experience and similar type of deployments across the whole stack of like, cloud, edge, and even constrained devices. But again, I think we are far away from this reality, but it seems that things, as you said,
I don't know, Nana. I don't know if we're that far away. Once again, Gen X and me is coming back and saying, hey, when I first learned about Kubernetes, there was this interesting reaction from people like me who've been working on real-time embedded systems, where you're just looking at that and say, why don't they call that process and threads? Because that sounds horribly familiar in terms of the concepts, and they're just like bringing it at a high level. But at the end of the day, they change names and so on, but the concepts are very similar.
Yes.
Where you have like pods that's more threads, the cluster, which is the process, and you have like an OS that
you scale
orchestrates all of
the
that.
applications, but actually you're just making more processes, and that's it.
Yeah, exactly. And so at the end of the day, when you look at that, you're just like, are we that far from having real-time embedded systems? They do have that, right? It's implemented differently, but the concepts are very similar.
Yes.
So what will it take for something like Azure Arc, or something that is about the pane of glass for many deploying, to understand that, this cluster is not using Docker containers. It's using, libraries and binaries, but the way I'm going to manage them, the way I'm going to receive logs and whatever from diagnostics and so on from them, is going to be normalized. It's going to be standardized. And then, once I want to bring it back to the standards of the industry that are used, if this little thing over MQTT is able to deliver, the diagnostics in a format that is universally understood, then this thing is contributing or participating in that broader Kubernetes story. And so I don't think we're that far away from that.
No, yeah. I mean, again, depending what what is far away these days is I think so there was a professor of mine that was saying this always, is like the change, the frequency of change is increasing. so yeah, which is, we are good at extrapolating from linear data, but like when you have this kind of exponential changes, then it's hard to imagine. So then coming back to this, what is far and what's near, I don't know.
I have there's the other way of seeing it, is that as we're getting older, we are slower to understand the change and to accept it. And so it looks faster. I think we were lucky to go through fundamental changes, in the past, and we're seeing one right now with AI, but there's one that no one really talks about, which is this componentization or containerization of IoT. We've seen the internet, we've seen mobile phones, we've seen 5G and wireless connectivity. And at the end of the day, these evolution and enhancements that seem to happen overnight, they're not happening overnight. They're brewing, they're growing. There's so many of them that it's hard to keep track. And we're focused on this, and then suddenly something happened there, right?
Yes.
And large language models is something, if you ask AI experts, that has been on their mind for some time.
They have been training this for like years, right?
Exactly. So it's and I agree that, as these technologies evolve, they are actually themselves helping accelerate the changes, right? So yes, hockey stick and exponential accelerating, but we also have new tools allow us to ingest these changes or abstract the complexity more and more, so that we don't have to be experts. I knew how my engine in my car, when I had a first car, was working, because I was doing the oil change myself. I was doing things. I have an electrical car. I have no clue how to do any sort of maintenance on that.
Yes.
And I'm fairly sure that the way it works is that someone comes in, connects a computer onto the CAN network, looks at the diagnostics, and that's it, right? I'm fairly sure that's something like that. But I don't need to know to operate that vehicle. Well, in the past, I needed to know, because it was making strange noises, and I had to go and fix it or add oil because it was leaking. So the technology has evolved in such a way that I don't need to, and I trust it to just work.
Exactly. Yeah.
And I think this is important. Like, the change is fast and accelerating, but the means to work with that technology, with these technologies, are also accelerating and enhancing. Like the fact that you can interact in virtual or augmented reality with an environment. Like, you're an operator, you don't need to understand that how the temperature information is coming from that gauge on that big tank. It's there, you can see it. You're the operator, and you can just leverage that information with the alert and the button to say, hey, I need maintenance because there's going to be an anomaly that has been detected, and that will require or that will actually generate a problem next week. So before
Yeah.
next week, I need to have someone fix that. And or as an expert of that thing and say, no, that sensor is bogus, because I know that I'm here, I see it's not wrong. And so I can now change the sensor because that's the sensor that's the problem. So you see, the operator now can interact with actual data in context in a way faster way, without having to understand the technology itself. And that's what he needs to operate, what they need to operate this kind of things, and to be more efficient in their work. And so I think at all levels, it's going to be the same. The code developer with Copilot technologies, some people, purists, are saying they don't have to write their code anymore. So like, why do we need developers? Well, we're going to have someone who knows how to build an application by using these new tools. And the prompts will be, the code. The prompts to these copilots and AIs will be the code. And that's sort of already the case today for search engines. If you think about it, the way you formulate the queries for a search engine today will give you different results. Those who understand how to ask the questions better, to have faster results, are the ones where they know the tool. And it's like someone who knows a development language really well. You'll know how to ask, how to prompt to get a certain result, and then you'll adapt, you'll change. Same thing for art. I mean, at the end of the day, we're saying, hey, with these AI generating art, what's the value of art? Well, the one prompting the machine to create the art and adapting, changing it because it doesn't look like the idea they had of it at the beginning is the artist, and it will still be an artist in the play.
Yes, I mean, he was able to contemplate all his experiences in the past, which are unique, as like no single human has the same experiences, and then come up with that question, and then basically, express himself throughout this even faster.
Without, I don't know how we came to talk about art. We started talking about IoT Builders.
That's a typical thing. Like once we go about this, we start talking about random things. But that being said, I think we are running out of time. So if there is anything else you wanted to add, I think we have a couple of more minutes.
I think the one thing is, well, first, thanks for having me here on the podcast. Keep doing it. I think it's a great platform. I love the IoT Builders name, and I love the way you guys and others are building communities or working with communities. I think we are not a big community around IoT, and that's fine. And I don't think we need to be a lot. I think we need to be passionate, and community building, I think, is and emulating communities is super important. So that's the one thing. The other one is, keep looking. If you are in the IT realm, keep looking around at all the technologies. Usually when you are in the IT realm, you're passionate about technology. Otherwise you would not be here, because that's a domain that requires understanding hardware, software, embedded, non-embedded, cloud, and so on. And so you're already in the right place. And I believe that that people who are in that domain are the ones who would be the builders of modern apps, like in the future. That's my final closing word for today, I guess.
That's excellent. Thanks a lot. And thanks a lot for joining. It's an honor to have you here and talk about, as I said, share this vast experience you have throughout the years. So that's pretty cool.
Well, you know where to find me. That was a joy. Thanks for inviting me, Ned.
Yes. Actually, you know what? I'll share this in the link afterwards. Some of the questions and some of the things we talked about. So people can also find you there. So excellent.
And if they want to reach me, that's Twitter here, and I'm on LinkedIn as well. Olivier Block, you can find me there. Connect. We can chat, and you know what I'm passionate about, so you know what to come talk to me about. All the way from IoT to art, right?
Yes. Excellent. Awesome. Then I think that would be it for today's session. So thanks everybody. Hope you enjoyed as much as we did, and then hope you see you next Wednesday. All right.
Bye. See you everyone. Bye.